Good morning, students. So now today we will be discussing the question answers of chapter number 4, which is structure of atom. So these questions are from the ncrt textbook, which you have been given for the last week homework. So now the first question is compare the properties of electrons and neutrons. So this is very easy. I have given you the topics while I've given you the video lecture. So electrons, protons and neutrons can be compared in the case of their symbols. Like they have electrons are symbol E and protons are written as P and neutrons as N. So these are the basic differentiation, and then electron has -1 charge, proton has +1 charge, and neutron does not have any charge. It has just neutral charge. So and the mass of the this protons is 1 upon mass of the electron is 1 upon 1837 of hydrogen mass. So and proton has 1 mass and neutron also has 1 u mass. So these are the basic things by which we can compare the electrons, protons and neutrons, and we can see that electrons are the negatively charged particles, protons are the positively charged particles, and neutrons are the neutral particles. Okay, so next question is, what are the limitations of J.J. Thomson's? So the limitations of J.J. Thomson's were that they failed to explain how positive and negative charge are arranged in an atom. So because he said that they are arranged close to each other. So this was the limitations of J.J. Thomson's model. Okay, this is a one line answer for 1 mark only. So what are the limitations of Rutherford's model of an atom? So Rutherford has limitations like you can also call limitations as in drawback or what are the disadvantages. So limitations and drawbacks are same. So drawbacks of Rutherford's nuclear model of atom was that as the nucleus of electrons are held together by the electrostatic force of attraction, so it would lead a fusion. That is in your book also. In this here you can see this. So the drawbacks. Okay, so the drawbacks are that because the revolution of, you can write from here to here. So these are the drawbacks in your own words, which means that because Rutherford said that the nucleus and electrons are held together by electrostatic force, so the attraction would lead to the fusion of nucleus with the electrons, and this does not happen. So Rutherford gave the explanation that the electrons revolve around the nucleus in a spiral path. But this was not satisfactory because Rutherford said that this is a positive charge and the electrons are revolving around it like this. So if it is revolving around this in a motion, so it will sometimes come to here also. This is an electron. So this was not satisfactory actually. So that is why it was the drawback of the Rutherford model of an atom. Next question is, describe Bohr's model of the atom. So Bohr's model of the atom is the most important question. In the Bohr's model of the atom, we have to explain that Niels Bohr gave a new model of an atom, and in his model he said that there are certain special orbits. Like he said that this is a nucleus plus charge, and he said that there will be certain orbits around the nucleus. So the one orbit will have the energy, they are called as the energy shelf, and the electrons are not allowed to move outside their energy shelf, and while revolving in the discrete orbit, electrons do not radiate any energy. So he gave 2 main points. That means that only certain special orbits, there are special orbits in which the electrons revolves. In which the electrons revolves, and the electrons are not allowed to move outside the energy shells. And this again one was that electrons do not radiate energy while moving. Okay, so these were the main, and this was a model that it's a K shell, then N shell, M shell, and one more N shell. So these were the shells. Okay, So I'll make it again. I hope everyone of you know that. Positive charge, first shell, second shell, third shell and fourth shell. Okay, so this is K, L, M, N, N. K has maximum number of it's called as the first shell, second shell, third and fourth, and K has maximum number of 2 electrons. L has 8, 8 and 18. So this was the Bohr's model. Okay, so next question is, compare all the proposed model of an atom given in this chapter. So in this chapter we have been given 3 model of electrons, like J.J. Thomson model, Rutherford's model and Niels Bohr's model of the atom, and then we have to compare all the models. Like in the J.J. Thomson's model, he recognized the subatomic particles, that means proton, electrons, and but failed to explain how they are arranged. Okay, the Rutherford model, it also explained that a tiny part is there in the atom, which is called nucleus, and which has all the positive charge in it, and electrons revolve around it, but it does not explain the stability of the atom. Okay, so Niels Bohr's model was the final model, and he proposed that the electrons are distributed in the different shells in a discrete energy around the nucleus, and if the atomic shells are complete, then the atom will be stable and less reactive. Because if the these shells are completely filled, then the atom is stable and they do not react with the other element. Okay. So next question is, summarize the rules of writing of distribution for electrons in the various shells of the first 18 element. Now we have to summarize it, like we have to tell how is the filling done in the atomic shells. So the number of electrons in a shells are fixed. That means the number of electrons are already fixed. Like it is a formula of 2n square, which means that if n is 1, then 2n, according to this, 2n square means 2 into 1, that means 2. The first shell will have 2 electron, which is K shell. Then L shell will have 2n square, that means if 2 is 2, that means it will be 8. So M will be 2n square, that means n equals to 3, that means 2 into 3 square, which is 18, and n equals to 2n square, which is n is when 4, that means 2 into 4 square, that means 32. So this is the K, L, M, N, which means that K will have 2 electrons maximum, L will have 8, M will have 18, and this will have 32 electrons. So this is the distribution of electrons. Okay. So next question is, define valency by taking examples of silicon and oxygen. So we have to define valencies. Valencies are the combining capacity of an element. Okay. So you have to give the definition also. Valencies are the combining capacity of an element. I have also given you while I have taught you the chapters. So if an atom has 1 to 3 electrons in its valency, 1 to 3 electrons in its valency, or in their valence shell. So valence shell means the outermost shell. Like this is an atom, so this is a nucleus, and this is the first shell, like K shell, and this is the L shell, and it is having 2 electrons, and L shell is having 1, 2, 3, 4, 5, 6. Okay, 6 electrons in this is the outermost shell, which is called as a valence shell. It has 6 electrons in their valence shell. So that means this is not the valency. So it needs 8 electrons in its valence shell, but it has only 6 electrons. So it needs 2 more electrons. So 2 electrons are less. So it wants 2 electrons. So 2 electrons is the combining capacity. So 2 will be the valency. So valency is a number in which it is not the number of electrons in its valence shell, but it is the number which are either lacking or either more. Okay. So if any element has 4 to 6 valence electrons, then it accepts the electrons, and if it has 7, it has 1, 2 or 3, it donates the electron. Okay, so the number of electrons by which an atom is reacting with the other atom is called as the valency. Example, the valency of silicon here is asked is, the valency of silicon is, silicon has atomic number 14. Okay, so according to this, it has a K, L and M shell. So 2 in the first shell, 8 in the next shell and 4 in the outermost shell. So the valency of silicon Si will be 4. Okay. So, but it does not mean that it has 4 electrons in its outermost shell, so it's a valency, because 4 is a number in which it cannot donate electrons, neither it can gain the electrons, but it will share the electron, just like the carbon. So, valency of oxygen, O2, is, the atomic number of oxygen is 16. Okay, so the valency will be, it's not 6, it's 8 actually. Okay, so the valency will be 2 and 6. So 6 is the outermost, is a number of electrons in the outermost shell. It needs 2 electrons, so 2 is the valency. Okay, so next question is, explain with example the atomic number, mass number, isotopes, isobars. All we have discussed already. What are the isotopes? So the atomic number is the total mass number of protons present within the nucleus of an atom, and mass number is the sum of the total mass of the nucleons. Then isotopes are the atoms of same element which have same atomic number, and isobars are the atoms of different elements having the same mass number. This all we have done in the last lecture video. So next question is Na+. So Na ion, this is the sodium ion, has completely filled Kn shell. Explain. So this will be explained as, so this sodium atom, so sodium is a metal. So sodium atomic number is 11. According to this 11, the configuration will be K, L and M, and it will be like 2, 8 and 1. So it has 1 electron in its outermost shell. If you draw the structure, nucleus, so it has protons and 2 electrons here, and then 8 here. Okay, and in the outermost shell 1 electron. So it is not stable because it has 1 electron in its outermost shell, and to be stable it has at least to have 8 electrons in its outermost shell, but which is not possible to have 8 to gain 7 electrons, so it will donate 1 electron. So it will become a sodium ion. So sodium will donate 1 electron and will become sodium ion. So after donating 1 electron, it will become sodium ion, because now sodium had 11 electrons, but sodium ion will have only 10 electrons, which means that after giving 1 electron, its valence shell will disappear, and the configuration of sodium ion will be only K and L, which is 2 and 8, and there will be no N shell. Okay, because this N shell will dissolve, because the 1 electron in the sodium ion, it will donate to some other atom and it will become stable. Okay, so next question is, if bromine atom is available in the form of say 2 isotopes, which is 79 Br35, which is 49.7%, and 81 Br35, which is 50.3%. So calculate the average atomic mass of bromine atom. Okay, so because these have the same atomic number, so that means these are isotopes which are having different mass numbers. So how we gonna find this? So in this question we have already given the percentage. So very easy to do this question. So the upper digits of the symbol of an isotope represent the mass. Okay, so the mass of first mass is 79, and the another mass of Br is 81. Okay, and percentage is also given. So the average atomic mass actually of bromine will be 79, because it's the this is the mass, and the percentage is given 49.7 upon 100 plus the other is 81 into the percentage is 50.3 upon 100. Okay, so it will be something 39.6 upon 100 plus 47.4 okay. Then on further calculation we will get, it will be because the 100 average will be same, so we can remove the decimal and this 100 will be cut, so here will be decimal and here will be decimal, so it will be 39.263 plus 40.743, which is 80.006, which is approximately 80 U. So the average atomic mass of bromine is 80 U. Okay. So after this question, the next question is okay, the average atomic mass of the sample of element X is 16.2 U. What are the percentage of isotopes 16X and this in this sample? So now again the same question. In this they have given the average atomic mass 16.2 U and they have given the isotope, but they haven't told us the percentage. So now in this question we have to find out the percentage. Okay, and so in this question we have to find percentage. So how we'll do this? Like now the number 1, the mass of 16X8 is isotope is 16U and the mass of other like 18X8 is 18U. Okay, because we know that this is the atomic masses and these are the atomic numbers just same. Okay, so we will take the percentage, so the percentage of sample 1 is let's say we take X%. Okay, so sample 1 means the first one, and the percentage of sample 2 is then it will be 100 minus X%. Okay, so the average atomic mass of sample X will be 16 into X upon 100 plus 18 into 100 minus X upon 100. Okay, so this already is given in the question, so which is 16.2 equals to 16 X 100 plus 1800 minus X upon 100. So the average will be 16X plus 1800 minus 18X upon 100. Okay, so this will come here, so 16.2 into 100 equals to 18 minus 16x minus 18x, 2x. Okay, so this 2x equals to, this will become 1620, so 1800 minus 1620 equals to 2x equals to so it will be 180, and then x equals to 180 upon 2, which is 90. Okay, so that means the x is 90 and the other sample will be x1 is 90 and x2 will be 100 minus x, which means 100 minus 90, which means 10. So the first sample, the percentage of this will be 90% and this will be 10%. Okay, so this will be 90% and this will be 10% in the answer. Okay, I hope it's clear now. Okay, now moving to the next question. If Z equals to 3, what would be the valency of element? Also name the element if Z will be 3. Okay, so what is the valency? It's a very simple question. So if atomic number is Z is 3, then the Okay, so configuration will be 2 and 1. It's K and L shell. So the valency will be 1. Okay, so next question is composition of nuclei of two atomic species X and Y are given, which is protons and neutrons. So give the mass number of X and Y. So the mass number of X, which is mass number equals to proton plus neutron, which is 6 plus 8, which is so mass number protons plus neutron. So then protons, okay, for this is 6 and 6, so it will be 12. And for the y it will be 6 plus 8, which means 14u. Okay, simple. For the following statement, by true and false, J.J. Thomson proposed that the nucleus of an atom contains only one nucleons. No, it's false. A neutron is formed by an electron and proton combining together, therefore it is neutral. Okay, yes, this is true. The mass of electron is about 1/2000 times of that of proton. It's true. Then the next one is an isotope of iodine is used for making tincture iodine. Okay, which is false. So that iodine isotope is not used. Okay, so this is false, this is true, and this is false. So next is Rutherford's alpha particle scattering experiment was responsible for the discovery of, it was responsible for the discovery of atomic nucleus. So isotopes of an element have the different number of neutrons. Okay, isotopes have different numbers of neutrons. Number of valency, because isotopes depends upon the mass number, and the number of protons are always same in an atom. Only the neutrons differs. So that is the different number of neutrons. Number of valence electrons in chlorine ions are 16, 18, 17 or 18. So the number of valence electron in chlorine ions are 8, because it becomes 2, 8 and 8 ions. Yes, it's 8. Okay, so next is which of the following is correct electronic configuration of sodium? So the correct sodium, if we ask about sodium ion, it will be this, but sodium atom is this 281. Okay, and the other one is complete the following table. This is a simple table. In this atomic numbers are given, and you can do this by seeing your book. You can also do this, like if it is 9, it should be 19 here, mass number 19, because number of neutrons here is 10, so number of protons will be 9, and then the number of electrons will be always equal to the number of neutrons, 9, and this is fluorine. Then atomic number 16, so mass number will be 32, and the number of neutrons will be 16, and number of this proton will be also 16, and then this will also 16, sulfur, and this is 12, 24, then this will be 12, and this is magnesium, Mg. So atomic number is mass number is 2, so this is proton, so definitely the electron will be 1, and neutron will be 1, and this atomic number will be 1. So this is hydrogen, and which is deuterium, because hydrogen generally the which we use have mass number 1 is the protium. So the other one is 1 atomic number, 1 proton. Okay, so this is done. So now your all the questions of exercise are done. I hope you understood the chapter. So rest of the things we will be discussing in our next lecture video. Till then, take care and study hard. Bye.